Hello, this is a Accuplacer review video for Kai. Hi, Kai. You sent me these 8 problems from the elementary algebra portion of the Accuplacer review packet. So this packet, right, it's really faded. But if you look in the fine print, you can see it's 2016. So I'm doing the problems you sent me from this middle section that's called elementary algebra. So I'll be referring to the sample questions, and then the answers are at the back of the packet. You already have those, but we'll be referring to those as well. Okay, so let's start with problem 4. This is a really classic problem that shows up on tests all the time. Excuse me, I'm gonna cough a million times, sorry. It's a picture that looks like this, and it says in the figure below, both circles have the same center. Okay, that's gonna be good information to know. The radius of the larger circle is r. If the radius of the smaller circle is 3 units less than r, which of the following represents the area of the shaded region? Okay, annoying shaded region problems are easy once you break them down. The way that you do it is you find the area of the bigger shape first. So in this case, it's a circle, the outside circle. Then you find the area of the shaded region and you subtract the shaded part from the bigger part, okay? So that's our general strategy. So we have been told that they have the same center. That's good. That means that the radius is the same for both of them. So we have a bigger circle, and then we have a smaller circle. Mine might not be proportionate. We have a shaded region in the smaller one. So what we want to do is we want to do larger circle area. That might seem backwards. The area of the larger circle, and then I'll write it in a more normal. The area of the smaller circle, and then we're going to subtract them. And the answer we get is going to be the answer to the problem. As we glance at the answers, though, we see, oh, look, there's no numbers. It's all just pi's and r's and 3's thrown around. Okay, so that's going to be confusing. But we'll power through and figure it out. Now, what's the formula for the area of a circle? I'm going to write it over here. The area of a circle is pi r squared. Okay, so we were told that the radius of the larger circle equals r. Okay, that's cheap. And then we're told that the radius of the smaller circle is 3 units smaller, so we can write r minus 3. All right, so that's what we have to go on. So using this formula and these 2 radius values, right? That's radius. Sometimes I do uppercase, sometimes I do smaller. It doesn't make any difference. The area of the larger circle is going to be simply pi r squared. And I'm using the uppercase because the problem specifically uses an uppercase r. Now, for the second one, we're going to take into account that the radius is 3 units smaller. So using this formula, I'm going to say it's pi r minus 3 squared. Make sense? That's the trick of the whole problem. Now we subtract them, and we can't really subtract them, so I'm just going to write it out. Pi r squared minus pi times the quantity r minus 3 squared. That, we look at this, is answer D, and that is correct. All right, just a note, some people, when they take tests, they like to just look at the answers and rule out the ones that don't make sense and kind of approach it that way. That's absolutely fine. What I'm showing you is always the more traditional kind of how to approach it step by step. But if you can look at the answers and rule some of them out, use that strategy too. That's a good one. All right, so this is, you need to know the area circle, and you need to know how to deal with this shaded region issue. Whenever there's a shaded region, do the biggest area first, and then subtract out what is shaded, and that will give you the non-shaded part as your answer. All right, 5 is a straightforward problem on multiplying polynomials. This is a really important skill that every algebra student, by the time you're at the end of Algebra 1, you should have this down. And what we see is that all that we're given is this, 3x minus 2y in a quantity, that means parentheses, squared equals. Okay, oh, I'm sorry, that was not a 1 there. It's just equals. Excuse me. So what we recognize is that these parentheses and that square mean we have to square the quantity. That means we have to multiply it by itself. Okay? Some people write them side by side and use what's called the FOIL method. I don't like that. I think that's needlessly confusing. I prefer this method called the dance. These are the boys at the dance studio. These are the girls. This is an old-fashioned like ballroom dancing studio that kids used to have to go to back in the day. And we start here with this first girl, and she dances with the first boy. By dance, I mean multiply. So 3x times 3x, 9x squared. Now this boy sits down, and the girl dances with the second boy. 3x times minus 2y, minus 6y. Now, she has danced with both boys, so she sits down and lets this girl dance. Remember that this girl's negative sign is going to go with her when she multiplies. Okay, so minus 2y times 3x is another minus 6y. So I'm going to write it underneath because those are like terms, so they're going to combine. And now this girl and this boy, they're going to end up as a positive 4y squared. Okay, now all the girls have danced with all the boys. And we add. That's our answer. And then we look at the list of possible choices, and we see that this is answer, oh, it's getting dark. I had to set my studio up because it was a sunny day, but now it's a dark day. Let me check and make sure. Oh, I did see, I wobbled it. Okay, so I look at my answers and I see that letter D is the answer that I want. Okay, so both of those were D's. Okay. So we've done 4 and 5. We're on to number 6. Turn the page. Okay. It says, if x is greater than 2, and we'll talk about why that's necessary, then x squared minus x minus 6 over x squared minus 4 equals. Okay, now whenever we have a little caveat like this, it usually is a hint that if we didn't have the caveat, there would be a problem. And I immediately look to the bottom and I see, oh, we have a denominator with a variable. That means we have to be careful that this doesn't equal 0. So we say to ourselves, x squared minus 4 cannot equal 0. And this means x squared cannot equal 4, and this means x cannot equal 2. Okay, so that's how they got that number 2. Now, why is it just x is greater than? The reason why is that we want to keep this answer positive. It cannot be equal to 0. And it's better if we keep it positive, because if it was negative, that would change all the signs up here and that would change everything else. So this just is a way of telling us, don't worry about other problems. Just focus on this. It's giving us protection against this blowing up or turning into infinity or creating negative signs that would cause us drama up here. So this is our friend, and we're just glad it's there. Now we can focus on this part of the problem without any extra drama. So what we see is we have two expressions that can be factored. Okay, that's what we're supposed to notice when we see this, is we're supposed to think, oh, let's factor this little puppy. I'm gonna write it here just for overkill. I would expect you just to squeeze your work up there, but I don't like to squeeze in a video. It's too hard to see. Okay, so what we're gonna do is we're gonna factor both of these. And the top, we remember, is a trinomial. The secret for factoring these, if we're lucky, is we're looking for a number that multiplies to the last number and adds to the middle number, the middle coefficient, because we're not worrying about the x. So I see that this would be x minus 3, x plus 2. They multiply to minus 6, and they add to minus 1, which is what we have right here. That is a quick factoring by inspection. Down here, we see that this is the difference of two squares, right? These are both perfect squares. And when we get those, we can factor them automatically like this, okay? So this difference of two squares needs to be in your head. And so then that means this would be x plus 2, x minus 2. All right? These we see cancel, leaving us with a final answer of x minus 3 over x minus 2. I'm going to box that as my final answer and then look on my list. Problem 6, x minus 3 over x. It's x minus 3 over x minus 2. So that is B. And that's the correct answer here. Okay? What's next on our list? 7. No. 6. No, this is 6. We skip 7 and we go to 8. Problem 8 looks like this. If equals minus 5, then x equals. Okay, so what that tells us is it's an equation. We see that because there's an equal sign, and we can solve for x. So I'm going to copy this onto my work page. It is 2x minus 3 times the quantity x plus 4. For parentheses, we always just say times the quantity equals minus 5. Beautiful. So this really becomes an order of operation problems. What do we do first? We always do the work in the parentheses first, but we can't add those. So there's nothing we can do there. There's no exponents or radicals. So now we're on to multiplying and dividing. This set of parentheses implies multiplication. It implies distribution. So we're going to do 2x minus 3x. Remember to take that minus along for the ride. And then minus 12 equals minus 5. Now we can combine like terms and add that 12 to both sides to get rid of it right there. Minus x equals positive 7. And then you can think of it as multiplying each side by minus 1. That works. And then we get x equals minus 7. Final answer, and that is answer B. Yay! Great. Okay, so this is just straight algebra, making sure that you know what order your operation should go. All right, we're up to number 10. Oh, I think I have room to do 10 here. Check to make sure I'm still in the viewfinder. Okay, problem 10 says, I know you can't see this, but you can look on your page. Here we have an inequality. It says, which of the following inequalities is equivalent to the inequality shown above? Okay, so what we have to do is simplify this and see if it matches one of these. Okay, so I'm going to copy it. 10. 20 minus 4 over 5x is greater than or equal to 16. Okay, the x is associated with the fraction. We'll deal with him later. The first thing I want to do is get rid of this 20. So I'm going to swim him over by subtracting. Now he's gone. Minus 4/5 x equals minus 4. All right, I'm going to put that over a 1 just because this is a fraction. I don't want any confusion about that. Now, I want to get this x by himself. How can I make this go away? I'm multiplying, so that makes me think, okay, I should divide, but I don't want to divide by negative 4/5. That looks like a nightmare. So I'm going to switch strategies, and I'm going to say another way to undo multiplication is by multiplying by the reciprocal, right? I can flip that fraction upside down. I'll get 5 over 4. I want a minus sign because I want those to cancel and make a positive. So I'm going to multiply both sides by minus 5 over 4. Here, the 5's cancel, the 4's cancel, the minuses cancel, and I just have an x. On this side, the minuses also cancel, and these 4's cancel. So what I'm left with is, I'm just going to show it here, it's 5 over 1, but I don't need the over 1 anymore. X equals 5. Positive 5. Oh, I'm sorry, it's not equals. It's an inequality, isn't it? Did you wonder why I changed it? Because I was confused. Aha! So what we have to remember is that when we multiply by a negative number, this flips. So it is no longer greater than or equal to. It's x is less than or equal to positive 5. Okay? So these signs do their regular thing. These negative signs do their regular thing. But when we multiplied by that minus 5, 4, we had to flip our inequality. And so it ends up being x is less than positive 5. That's the correct answer. It's A. Beautiful. Okay. So now we're done. 4, 5, 6, 8, 10. We're on number 13. This, take a break in this series of problems anytime you need to. There are 12 problems in all. We're starting the 5th. So if you want to take a break now, if your brain feels overwhelmed, do that. Go outside for a walk is the best thing you could possibly do. Go get some fresh air and come back and tackle a few more. 13. Lucky number 13. Again, I know you probably can't read this, but you can look on your own page. For which of the following equations are x equals 5 and x equals minus 5 both solutions? Okay, so this is the answer we want. All right, and we can work backwards. We know that if x equals 5, then we probably at some time had x minus 5 equals 0, didn't we? And then we added 5 to both sides and got that. So my brain is helping me work backwards. And this must have been x plus 5 equals 0. Because then when we subtracted 5, we would have gotten this as our answer. Okay, so working backwards, we're trying to find out what was the trinomial we started with. We can do this much. Then we can remind ourselves that these two were in quantities multiplied against each other. We must have had something that looked like that. And if it didn't signal you earlier, your brain may be signaling you now, saying, oh, that difference of 2 squares. We can write this with the minus sign first or the plus sign first. It doesn't matter as long as there's one of each. And we recognize This old friend, the difference of two squares, has just the pattern we're looking for, doesn't it? It looks just like this. They're exactly the same. So what we can see is that this, if this is the pattern we have, which it is, how would we rearrange these pieces to get this? It would be x squared minus 25, wouldn't it? Because the root of this is x, which we would put there, and the root of this is 5, which we would put there and there. So that is how we can see, and we know it must have been equal to 0 when we first set it up. That problem, or solution B is the correct answer, okay? Solution A is not a thing, and these have complicated pieces that we don't need. This is the one that works for us. This is a difference of two square patterns. Make sure you can recognize this pattern when it pops up in your life. Just double checking to make sure that is B. And that's correct. Okay, number 14. 14 is a nice fraction problem. That's all it really is. It says if x equals 0, then, and then we've got a over x plus 5a over x minus a over 5x equals. Okay, so we're just supposed to add these fractions. All right, so let me copy them. It is a over x plus 5a over x minus a over 5x. Okay, and then the other thing I just want to point out is that it also says if x equals not 0. And we see, oh yeah, because if x were 0, that would cause us some massive problems in our denominators. This is the good news that we're given to say, don't worry about your denominators blowing up. Okay, so what is the number one magical rule for adding and subtracting fractions that you learned a billion years ago? Denominators must match. So before we start trying to combine anything, we have to adjust these first two to equal 5x. Remember that we find our least common multiple, and in this case it would be 5x. So I'm going to fix that with a green pen. This one we're going to have to multiply by 5 over 5 to get the 5x on the bottom. This one we're going to have to multiply by 5 over 5 to get the 5x on the bottom. This one is good to go. Okay, so that shows the adjustments. Remember that in an expression, as long as we're multiplying top over bottom with the same number, we're fine. We're keeping things in balance. If there was an equal sign, we'd have a slightly different set of facts to deal with, and actually it's easier. But with an expression, we multiply top and bottom by the same quantity, and we're good. All right, so what do we have now? We have 5a, I'm just going to do the numerators right now. 5a plus 25a minus a. Notice that the bottoms all match. So our work there is done. All we need to do is copy that forward. 5a plus 25a is 30a minus a equals 29a over 5x. That, my friend, is our final answer. And that, for 14, should be answer C. Beautiful. All right, I'm going to turn the page and start 15 at the top for a very specific reason. What are we on? 15? Yes. Problem 15 looks like this. Here's a number line with some solution graphed on it, and it says the solution set of which of the following inequalities is graphed on the number line above. Okay, as we look at this, we see, well, this is a really easy solution for us to write. There's a solid dot at the 2, and then it's all these less thans. So just by looking at the picture, we can see that the solution is x is less than or equal to 2. It does include 2 because there's a solid dot there. Remember, if we didn't want to include 2, we'd put an open circle. So we can see that the solution is very simple. It's x is less than or equal to 2. But the answers are all more complicated. Ay, ay, ay. So what that means is we have to simplify each one of these answers to see which one is the same as x is less than or equal to 2. Now, I would encourage you to test them before you circle them, but I also would say trust your instincts and see which one do I think of these is going to be x is less than or equal to. But don't just look at it and guess. Actually test and make sure that you get the right answer. And so what I'm going to do rather than guessing is I'm just going to go ahead and calculate for each one of those answers. We'll compute the actual simplified version. So the first one is 2x minus 4 is greater than or equal to minus 3. All right, so we're going to add 4 to both sides. To swim all the numbers this way, we get 2x is greater than or equal to 1. X is greater than or equal to 1/2. No, that's not what we're looking for. We're looking for this. B. 15b, 2x plus 5 is less than or equal to 6. Subtract 5 from both sides. 2x is less than or equal to 1. We get x is less than or equal to 1/2. No, that is not what we want either. Okay, so we're ruling them out. C. 3x minus 1 is less than or equal to 5. Okay, so we'll add 1 to both sides. 3x is less than or equal to 6. X is less than or equal to 2. Hey, that's what we want. So it's looking like item C is our winner. Let's just test D because maybe you would have thought that looked like the answer and you would want to try it. So we'll just go ahead. It is 4x minus 1 is greater than or equal to 7. So we'd add 1 to both sides. We get 4x is greater than or equal to 8. Oh, I'm sorry, 4. And we get x is greater than or equal to 2. So D might be the one you guessed to try because it does come out to a 2. It's just that the inequality is pointing in the wrong direction. So that's also a no. All right, so C is our lucky winner. Again, guess but test. Absolutely. Okay, and that is the right answer. It's C. Okay, good. We're done with 15. We're now going to do 17, 18, 19, and 20. Here we go, 17. Which of the following is a factor of both x squared minus x minus 6 and this, x squared minus 5x plus 6? So what I'm going to do is I'm going to write those two expressions down, x squared minus x minus 6 and writing them carefully because the pluses and the minuses can throw us off. And we're asked which of the following, and we see they're all binomials. It's a letter and a number with a sign in between. Which one is a factor? So that gives us a hint. Oh, let's factor these. So in both cases, we're looking for a pair of binomials. X will be in the beginning. We want two numbers that multiply to this and add to that. And if it helps you, remind yourself that's a minus 1. So my brain sees this one would be x minus 3, x plus 2. They multiply to minus 6, They add to -1. Yay, I feel good about it. Now we're going to do the same thing here, but the numbers have to add, to, or they have to multiply rather, to +6 and add to -5. So that one I see is this. They multiply to +6, they add to -5. Okay, so we have now factored both of these expressions, and we're looking for what term they have in common. And we can see it's right here. It's x minus 3. And is that one of our choices? 17. X minus 3, that is A. And I check it with my right answers that I have close at hand, and that is indeed A. Yay! 18 is another factoring problem. We're given an expression, just a second, I'm turning my page. We're at the top of the next page, 18. We're given this fraction, and there's not even any words to it. Oh boy, okay. So it's 10 times x to the 6th plus 8 times x to the 4th over 2 times x squared. And we can see by the answers that there's no denominator. Okay, so that sometimes the answers give me hints, because what this tells me is I must be able to reduce this somehow. All right, because there's no denominator anymore. So I'm guessing, look and see if 2x squared goes into these numbers and see if I can cancel it. And as I'm doing that, I remind myself, we can't ever cancel when we're adding. What we're gonna have to do is see if we can factor out a 2x squared from each of these. We'll factor first and then we'll cancel. So I look and see, can I pull a 2x squared out of both of these? Well, yes we can, because they're both even numbers. So that tells us 2 will come out. And then we see that we have more than enough x's to take 2 of them out, right? This is 6 x's, this is 4 x's. I want to cancel 2 of them. Beautiful. So what I'm going to do is I'm going to rewrite this numerator, and I'm going to factor out the 2x squared. So now I'm comparing this number to this and seeing what's left. When I start with 10 and basically divide out a 2, that leaves me with a 5. And then with my exponents, I subtract. I have 6 x's, I'm pulling out 2, so that leaves me with 4. And then I'm going to do the same thing here. When I factor out the 2, that will leave me with a 4. And then I have 4 x's, and I want to take 2 out, so that leaves me with 2 more. Okay, all I've done so far is just factored those out. Now I can cancel. We can only cancel when we're multiplying. But now this is being multiplied against all of this, so it's fair game for canceling. So that means my final answer is right here. It's 5x to the 4th plus 4x squared, and that is letter C. And it's correct. All right? So remember, we can cancel, but only after we have factored. 19. 19 is a nice little geometry problem. Are you ready? I prefer geometry problems when they draw us a little picture, but they don't, so we have to draw our own picture. It's fine, we can do it. Okay, I'll read it to you and we'll draw. A rectangular yard has an area 96 feet. Okay. So I'm just gonna draw a rectangle. I'm not gonna worry about being proportional. And we know that the area equals 96 feet, and it must be squared, okay? If the width of the yard is 4 feet less than the length, okay, the width is 4 feet less than the length, so let's call this L, and let's call the width L minus 4. Does that make sense? And we can write equals W, just so that we know that's the width, is the length minus 4. Okay, And we are supposed to find out what is perimeter. And just to remind you, the perimeter are all the sides added up. So we're going to have to use this area information to figure out what the length and the width are, and then we'll add going around. Okay, so what we know is that for any rectangle, area equals length times width, right? So in ours, 96, that's our area, equals L times, and I'm going to put it in a quantity, L minus, whoops, I wrote a plus, it's minus, L minus 4. I make my L's loopy so that they don't look like ones. 96 equals, now I'm going to multiply this, L squared minus 4L. Okay, now I'm seeing, oh, there's a trinomial just waiting to happen in here. I'm going to subtract 96 and bring it over, and we will get L squared minus 4L minus 96 equals 0. Okay, that looks like a nice little trinomial that I can factor. The 96 is kind of big and a little scary, but I'll show you a trick to deal with that. When you're trying to factor a big number like that by inspection, it helps to break the 96 down into its prime factors. So let's do that over here. We're looking for two numbers that multiply to 96. And my brain goes to, let's see, how about 32 times 3? That does it, right? I see that these are both multiples of 3. So that's 3 times 3, and this is 2 times 3. So I know this is true. Okay, 3 is prime. Good boy. Done. 32 is 8 times 4. And this, I know, breaks down in just a whole bunch of 2's. 2, 2, 2, 2, 2, 3. I brought that one down. So these are all the prime factors of 96. This helps me play around with them because I only want a difference of 4, right? So what I'm going to try doing is taking this list of factors. Let's just try chopping it in half because I want my two numbers to be fairly close to each other, right? The two numbers that multiply to 96, but add to a difference of 4. I know I want them to be numbers almost the same size because they're only 4 different. So let's just try chopping our list in half and multiplying this clump and that clump and see if we get close. 2 times 2 times 2, that's 8. 2 times 2 is 4 times 3. Look, we got it on the first try. The difference between 8 and 12 is 4. So what that means is that if we use our pluses and minuses wisely, we can use these two numbers. We know it's L. Let's see, to get 96, one of these numbers has to be negative, one has to be positive. Then we want them to add to minus 4, so I'm going to make it L minus 12 and L plus 8. We know that 8 times 12 is 96. We have one negative, so there's that negative. And then when we add them, we get minus 4. Okay, good, we did it. Okay, so now we have factored this big expression. Now our job is to solve for L. In both cases. So either L minus 12 equals 0 or L plus 8 equals 0. That's using our zero product theorem. If these two things multiply to 0, then either this one is 0 or that one's 0. This one would tell us that the length is 12. This one would tell us that the length is minus 8. I don't think that's true, do you? In geometry, we can eliminate our negative solutions because this can't be minus 8 long. That doesn't make any sense. So our length we know equals 12. Our width is 4 units smaller, so we know that our W, our width, equals 8. Oh, that's so happy, right? And sure enough, that checks out because we know 8 times 12 is definitely 96, and we were told that our area is 96. So now all we need to do is find our perimeter, which is going to be 12 plus 8 plus another 12 plus another 8. Each of those are 20, so the total is 40 feet, not squared because it's the perimeter, it's the distance around. The perimeter is 40 feet, and that is answer A. Guess what? It's right. You just check, I've got papers all over the place. 40A, that's correct. Okay, so we used geometry to set it up, and then we used algebra to solve. And then we went back and did a little more geometry. It's quite a workout, isn't it? Okay, last problem. 20. My son's back. Okay, problem 20. It says, oh, this is a hard one. This is a very hard one. On Monday, it took Helen 3 hours to do a page of science homework exercises, okay? So on Monday, her rate equaled 1 page of exercises for every 3 hours. Okay? On Tuesday, she did more homework. The next day, she did the same number of exercises in 2 hours. So, her rate is 1 page for every 2 hours. All right, she picked up some speed, didn't she? If her average rate on Monday was P exercises per hour. So now we're not talking about pages anymore, we're talking about P. So we're saying her rate on Monday is now equal to P over 1. P number of exercises for every 1 hour. So we're completely changing the way we're writing this rate. Then the question is, what was her average rate on the next day in terms of P? Okay? Question marks in algebra, as we know, can often be filled in as X. Now, this is a really hard problem, but what I want you to notice is that we've set this up almost as proportions. Her rate on Monday, as we wrote it the first time, over her rate on Tuesday, as we wrote it the first time, right? 1 over 3, 1 over 2. That was fairly easy to get. And now we're going to ignore these ones. Oh, we can leave them in there. Monday, we're calling that rate P over 1. And Tuesday, we don't know what to call it. So we're just calling it X. We're going to solve for X. Okay, we're not solving for P, we're solving for X. All right? Because that will give us her new rate with the P in it. It's very weird. Okay, whenever we have 2 fractions, and these are complex fractions, but it still works, we cross multiply, right? So we get 1/3 times X over 1 equals 1/2 times P over 1. Okay, so we can squish these together, but before I do that, what I'm going to do is say, what do we have to do to get our X by itself? We're going to have to multiply it by 3 over 1, aren't we, to cancel that. So let's put the 3 over 1 over here too. Okay? So I'm just using basic algebra techniques to solve. Now, yeah, I hope you can still see okay. The sun's behind the trees now. This all cancels. And here we have a 3 in the numerator and a 2 in the denominator. So our final answer for X, the rate that goes here, sorry, pointed to the wrong place. The rate that goes here is 3 over 2P. And when we look at our answers, it's too dark again. that's better. We see that answer D is 3/2p exercises per hour. They all have the same description on them, so we know that's right. 3/2, this is D, and guess what? That's the right answer. Okay, so that's how many exercises per hour she did. Because that's our new rate. First was pages per hour, then we switched it to exercises per hour. This is a really, really difficult problem. So if this one confused you, don't feel bad. The other ones are pretty straightforward algebra that I encourage you to make sure, dig into your memory, make sure you remember. This one you might not have covered anything quite like it. It's quite a difficult problem. But we got through it and it's okay, right? Now if you have one like this, you can figure it out. All right, I hope this helps. Please text me right now and tell me if you still have questions on any of these, and let's move ahead from here. All right, thanks, bye.